What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet. And what we're going to be doing today is talking about the differences between observational studies and experiments. If you haven't done so already, make sure you go and watch my latest video on sample surveys. That is going to be very important for today's discussion. Let's jump right into it. First thing we want to define is what is an observational study. An observational study is just what it sounds like. It's a study where investigators are just doing observations. They're not really setting this up. They're kind of just walking into a scenario and observing things that are going on and trying to draw some type of conclusions. We can use existing data, meaning it doesn't have to be observed live in an observational study, but either way when we do this, we cannot prove causation. We can only show that there's a relationship that exists between variables, but we can't say that one variable causes another one. Let's give a couple of examples of what an observational study could look like. One could be an observational study that occurs in a classroom. All the time, if you're a teacher, you get observed by principals, assistant principals, and superintendents. And what happens is they come in the room and they just observe what's going on. They may look to see how many students are participating in your classroom. Well, in this case, what they're seeing is see if a relationship exists. They could see if a relationship exists between how many students are in the front of the room participating and how many participate in the back of the room. However, they can't prove causation, meaning they can't say that sitting in the back of the room causes a student not to participate. However, they could notice and observe that students in the back of the room tend to participate less. Let's look at another example of an observational study. One could be the attendance data from Yankee Stadium. Someone could look at how many people attended Yankee Stadium from year to year and then try to think of why the attendance data is changing. They might say something like, I noticed that there's a relationship between the attendance to Yankee games in the summer and Yankee games in the fall. Maybe the attendance is higher in the summer than in the fall. What they couldn't say is something that, like, warmer weather influences more people to go to Yankee Stadium. Because an observational study cannot prove a cause, it can only prove that a relationship exists. And one final example could be the migration patterns of mountain gorillas in Virunga National Park. We could study this and see how the gorillas are moving through the park, but we cannot prove causation. We could say that it seems that more mountain gorillas exist in this region than another, but we can't say that mountain gorillas exist in this region because the elevation is higher. We don't know why they exist in a certain region. We can just recognize those patterns. Let's see if you can answer a question about an observational study. Which scenario here is best described as an observational study? In this case, we want to go through it and see which one is an observational study. Part A is not an observational study because it's actually a sample survey like we learned about in the last video. Here we're asking every 10th student entering the school if they eat breakfast in the morning. We're not observing, we're actually conducting a sample of the population. Choice B is the correct choice for an observational study. Here, a social researcher wants to learn whether or not there's a link between attendance and grades. She gathers data from 15 school districts. They're just observing what's happening with attendance, and they're going to try to draw some relationship conclusion. Choice C is also a sample survey like we learned about in the last video. Here, there's a researcher that's distributing a questionnaire. Because of that link between interacting with the participants, this is a survey. And if we look at choice D, that's what we're going to learn about right now. That's an experiment where we're trying to determine some type of correlation between two items. Let's define an experiment for our notes. You're probably used to experiments from your science class, and what the formal definition of experiments is, it's where investigators apply 2 or more treatments to the subjects and then proceed to observe the effects of the treatments on the subjects. In a randomized experiment, investigators control the assignment of treatments by randomly assigning the treatments to the subjects. This is very different from the observational study. In the observational study, there is no control of the assignments of what's going on. You simply enter some type of area and observe something, whether it's a classroom or whether it's data that already exists. That's the main difference between an experiment and an observational study. In the simplest experiments, the subjects are randomly divided into two different groups. One group is called the treatment group and receives the treatment that you want to test, and the other group receives some treatment that is not what you want to test. Some treatments don't need a control group, but it's always better to have them. There's a few basic things that you need to have in each experiment. The first thing is you have to have a subject or something you want to study, whether it's a participant or some type of group that you want to study. You need to have a response variable. That's a variable not controlled by the experiment, and it's measured as part of the experiment. And finally, you need to have the treatment, which is the condition to which subjects are randomly assigned by the experimenter. Here's an example of an experiment. Let's say I wanted to see the effect that Red Bull has on having students do homework. Here the subjects would be students. My response variable, which is the one that I'm measuring, would be how much homework they do, and the treatment would be the condition to which the subjects are randomly assigned. In this case, I'd be giving one group Red Bull, and I'd be giving another group some other drink that wasn't Red Bull. Maybe that drink was just water or something without the active ingredients that Red Bull has. When you're designing an experiment, you should always have three things. You should always have random assignment, which means we randomly put the subjects into two groups. In the Red Bull homework example, decide which students randomly will be placed in the group that get Red Bull and which subjects will randomly be placed in the group that doesn't get Red Bull, but you do it randomly. The next piece is to keep everything for the same for the two groups except the treatment. So one group is going to drink the Red Bull, one group is not, but everything else should be the same. They should both drink the same amount of whatever drink at the same time of the day, and the group should have the same number of participants in them. Everything is the same except the Red Bull in one of the drinks. And then, of course, at the end, you have to compare the two groups. If I don't compare what the difference was at the end, then what was the purpose of the experiment? We have to compare them at the end to see if the treatment, or the Red Bull in this case, had any effect on the amount of homework students did. Let's see if you can try an example. To answer this question, we want to recall the definitions of response variable and treatment. Well, if we think about response variable, that's just the variable not controlled by the experimenter and measured as part of the experiment, where the treatment is actually the conditions that are randomly assigned that we want to measure. If I look at this one, the correct answer is choice B. This is what we're measuring here. We're measuring if walking for half an hour 3 times a week and reading a book for half an hour 3 times a week has some type of effect on blood pressure. See if you can answer this question. Which statement about statistical analysis is false? This one here is just a definition, and the one that is false is choice C. Observational studies can determine cause and effect relationships. That is false. Think back to the most simple definition or the most simple example of an observational study, which is an observation in a room where a teacher is teaching their students. If someone comes in and observes, they cannot determine that sitting in the back of the room causes students to participate less. They could observe that there is a relationship that the students in the back of the room did participate less, but they can't determine cause and effect relationships. That's something that can only be determined in an experiment. In this question here, describe how a controlled experiment can be created to examine the effect that ingredient X in a toothpaste has on preventing cavities among 50 volunteers. When we create an experiment, remember that we need 3 pieces. We need to have our participants randomly divided into 2 groups. Everything should be the same for those 2 groups except the treatment, in this case, ingredient X within a toothpaste. And finally, we have to compare them at the end. So our answer could look something like this. Volunteers for the experiment should be randomly divided into 2 groups of 25 participants. Of course, because there's 50, if we want to keep them the same, there should be 25 in each group, randomly assigned. The first group will use a toothpaste that includes ingredient X, while the second group uses a toothpaste that does not have ingredient X. Both groups will only use the toothpaste to brush their teeth, and both groups will use the toothpaste for the same length of time, maybe a month, maybe a week, whatever. And then, of course, at the end of the month, those two groups will be compared with regard to the effective cavities when using ingredient X. See if you could answer this question. This one here cannot be an experiment. There's no two random groups with some type of treatment that we're measuring, so it's clearly not an experiment. A census is a measurement about an entire population of people. This is not a census. An observational study, this is. We're using existing data and we're looking for a relationship between the data, and this is not a sample survey. We're not taking a sample of the population and using it to draw conclusions about a larger group of people. So this is choice C, an observational study. Let's try one final question. See if you can find which data collection method is described in this situation. This one is clearly a controlled experiment. There's a treatment. We're being divided into two equal groups where one group just gets the treatment and the other group doesn't. So this one is choice A. I hope this video today helped you realize the difference between observational studies and experiments. Until next time.